In this lesson, we're going to again discuss adding and subtracting square roots, but the focus this time will be on where we're going to have variables involved. In the previous lesson, if you recall, when we added and subtracted square roots, the focus here was just on radicals that did not contain any variables. And then we had to make sure that was simplified. So we simplified and then we combined like terms. All right, so that was the focus in the previous lesson. This idea is going to be needed for this as well. Now, before we go on, it's important that we remind ourselves what we mean when we say like radicals. So like radicals. So remember, like radicals. And like radicals are radicals we can combine. So radicals we can combine. And when I say that, I mean like adding and subtracting. So I either add or we can subtract. All right, so in other words, if you go back to the previous lesson, the very first one we looked at, so these are like radicals because now I can add those. 5 squared root of 2 plus 2 squared root of 2 is 7 squared root of 2. So that means I can combine them into one term. Okay, so that's what that means. All right, and so let's kind of talk about what like radicals are. So remember, like radicals have the same index, So either they are cube roots, or they are square roots, or they are fourth roots, or fifth roots, and so on. In particular, though, and they also have the same radicand. They have the same radicand. All right, so if we go back to the previous lesson, you'll see that I'm dealing with square roots. So they have the same index. The index is 2. The radicand is also 2, so they're the same. All right, so over here, notice that these are like terms because the radicands are the same. They're 3's, and the index in both cases is 2. Square root, okay? So I'm going to just write some terms, and then we're going to discuss whether or not they are like terms. So determine if these are like terms. Okay, like radicals. So number 1, I have 7 cube root of x plus, comma, 8 cube root of x. Okay, so are these two terms like terms? So in other words, if I want to add them, could I add them? If I wanted to subtract them, could I subtract them? All right, so remember, like terms, like radicals, they have to have the same index, and they do have the same index, right? They're both 3's, cube root. Are the radicands the same? Yes. So those are like terms. So the answer is yes. Those are like terms because they have the same index and the same radicand. All right, number 2, what if you had 3x square root of 2, comma, 4 square root of 2? Are those like terms? Now, that may confuse some of you. And the reason it may confuse some of you is this. So you see, you may say, well, according to what you just said, they have to have the same index, the radical. That's true. They're both 2's, right? And the radicands are the same. But the problem is this variable right here, that variable that's attached with this term. So I want to remind you about something that you learned in a previous course. If I have this, now listen carefully. If I have 3x plus 5, are those like terms? Can I combine this? No, because this does not contain an x, right? So the same thing applies here. You see, I have 3. If you want to rewrite this, you can rewrite this as 3 square root of 2 times x. So notice, if that x wasn't there, would these be like terms now? Yes, those are like terms. But the fact that I have an x there, just like over here, if that x wasn't here, then I could combine 3 and 5. 3 plus 5 is 8. But this is not a 3, that's a 3x. So that term is different than that term. All right, so these are not like terms because of this factor of x. All right, so the answer is no there, since one term has a factor of x and the other does not. Okay? All right, so if I had 3x square root of 2 plus 4x square root of 2, then will they be like terms? Yes. I'm sorry, I did not mean to put addition, I meant to put comma. So are these terms like terms? Yes, those are like terms. All right, so that's a yes here. It's kind of like saying this. Okay, remind, 3x plus 5x. Can I combine those? Sure you can. 3x plus 5x is what? 8x. Same idea here. Okay? So when we talk about these problems, it's going to be, it will be a mixture of these. So sometimes the variables will appear in the radicand. Sometimes they won't appear in the radicand, but will be part of the radical expression. All right? Number 4, what if I had this? What if I had 3x squared square root of 5, comma, 2x squared square root of 5? Are those like terms? First of all, what I would do first is check the radical itself. So they're both square roots. They both have the same radicand 5. Now check the variables. You have variables. In order for them to be like terms, they have to have the same variables raised to the same power. So I have an x in both, and they're both being raised to what power? The second. So yes, those are like terms. Okay. Number 5, suppose you had 4 square root of 3x, comma, 6 square root of 3x. Are those like terms? Check the radicals first. I have both square roots. The radicands are both the same, and that I don't see any other variables attached to these. So the answer is yes. Okay. So if I wanted to add them, I can. So in other words, if I wanted to say 4 square root of 3x plus 6 square root of 3x, then that's what? 4 plus 6 is 10. So that's 10 square root of 3x. That's what that means. Okay. Number 6. What if you had 2 square root of 3x, comma, 3 square root of 5x? Are those like terms? No, those are not like terms. And the reason is that the index are the same. They're both square roots, but the radicands are different. This is a 3x and this is a 5x. So no, since the radicands are different. All right. Okay, and then I think if we do one more, I think we should be okay. We can continue on with the topic. So if I have 6x squared, comma, 3x squared square root of 5, are those like terms? What do you think? No, right. They're not like terms because look, if you covered up the square root of 5 right here, would those be like terms now? Yes, because 6x squared, and let's say if I would add them, 6x squared plus 3x squared is 9x squared. But the fact that there's a square root makes things a little bit more challenging for us. So remember, like radicals, see this has a radical and this does not, right? So the fact that this has a radical, this does not, automatically says that those are not like terms. So the answer is no, and I'm going to say since 6x squared does not have a factor of square root of 5. All right, so those are not like terms. Now if I change it to this, if I change it to 6x squared square root of 5, comma, 3x squared square root of 5, then the answer will be yes. Okay, the answer will be yes. All right, so I think that our discussion here should help us with the main part of this topic, and that is to add and subtract square roots. Okay, so let's start looking at some examples. Okay, so this is going to come into play now, so you need to know whether or not you're dealing with like terms before you can add or subtract. Okay, so the directions again will say add or subtract. Add or subtract. Okay, so add or subtract. All right, so number 1. So let's suppose we had the square root of 205. Okay, I meant square root of 20r. That's an r. All right, not 205, sorry. Minus 3 square root of 45r minus 6 times the square root of 80r. Okay? All right, now, you need to make sure, remember, none of those look like they're like terms, because even though the radicands are, I'm sorry, the indexes are the same, they all square roots, those three are square roots. The issue is that the radicands look different. But remember, in the previous lesson, you need to see if you can simplify the radical. So what I would do at this point is this. I would go ahead and rewrite this using a product rule. All right, so according to the product rule, this is the square root of 20 times the square root of r. Y'all agree? Okay. Minus 3, and this will be the square root of 45 times the square root of r. Minus, and this is 6 times the square root of 80 times the square root of r. Okay. Now, you need to see if you can simplify the square root of 20. So go off to the side and do that. Just do that here. Square root of 20, I can simplify. Let's think about what that is. The 4 is the largest perfect square that goes into 20. So it'll be the square root of 4 times 5. And then using the product rule, that's the square root of 4 times the square root of 5. And the square root of 4 is 2, so it's 2 square root of 5. So that goes here. So this is 2 square root of 5 times the square root of r. Okay? And then remember, the square root of 5 times the square root of r, I can now rewrite this as 1 radical. So it'll be 2 times the square root of 5r. So basically, all you're doing is taking the square root of 20 and seeing if you can simplify it further. All right, but it's important that if you do it like this, you come back and you write this as 1 radical. 5 times r is 5r. So since the index is the same, I can multiply those two radicals. I'm using a product rule. Okay, over here, let's talk about the square root of 45. Square root of 45, the largest perfect square is 9, so be that's going to equal the square root of 9 times 5, right? And so that'll be the square root of 9 times square root of 5. And so I get 3 square root of 5. So it'll be 3 times, and then this is 3 square root of 5 times the square root of r. So this becomes 3 times 3 is 9, so it becomes minus 9 square root of 5r. Okay? And let's talk about the square root of 80. So the square root of 80, let me go ahead and do that here. Square root of 80 will be, let's see how these are all 5s? Let's divide 80 by 5 to see if what I get is a perfect square, and it is 16. So the square root of 80, I can write as the square root of 16 times 5. And the product rule says that the square root of 16 times the square root of 5. And so this will be 4 square root of 5. So this becomes minus 6 times 4 square root of 5 times the square root of r. And so 6 times 4 is 24. So it'll be minus 24 square root of, now the square root of 5 times square root of r is the square root of 5r. Okay? Now, so notice I simplify these radicals as much as I can. Okay? So the square root of 20r, square root of 20r is this. 3 times the square root of 45r is this. 6 times the square root of 80r is this. Now, are those like terms now? Yes. So all three terms are like terms. All three terms are like terms. They all have the same index. They're all square roots. And the radicands are the same. See what I had to do? Now, you see how I wrote them in steps, and I kind of did some work on the side so it doesn't get too messy in this little area? It may be a good idea for you to do that as well. Now, all you do is just add their coefficients, add or subtract. So I have 2 here. Use your calculator. 2. I'm subtracting 9 of them, so 2 minus 9, just like this. And then I'm subtracting another 24, so minus 24, and notice you get a negative 31 of them. So the answer is going to be a negative 31 times the square root of 5r. Okay? All right, so number 2. Number 2, let's suppose we had this in number 2. We had the square root of 9x to the 4th minus the square root of 36x cubed plus the square root of x cubed. Okay? Now again, probably the best way to do this is kind of like the way we did here. So I went ahead and I used the product rule first to help me to organize my information. And let's do the same thing here. So do y'all agree that the square root of 9 times x to the 4th, according to the product rule, I can write this as the square root of 9 times the square root of x to the 4th. And the same thing here, the square root of 36 times the square root of x cubed. And the same thing, well, here I'm just going to leave it as square root of x cubed. Okay? All right, now, Let's talk about some of these we're going to have to remind ourselves from previous lessons. So let's talk about the square root of 9. So 9 is a perfect square. What's the square root of 9? 3. Now remember, when we simplified square roots that contained variables. So the question is, and let's see if you remember this, can I simplify this? So how do you remember, what do you remember regarding a previous lesson, how to simplify the square root of a variable raised to a power? Okay, so you can simplify this because the exponent is greater than or equal to the index. So since 4 is greater than or equal to 2, then I can simplify that. And so remember, all you do is ask yourself, what times itself twice is x to the 4th? And so the answer is x squared, right? X squared times x squared is x to the 4th. And so remember what we did, just as a reminder, all we did was we said 4 divided by 2 is 2. Now, remember, this is even, so even is easy. It's the odd, remember, that you have to do something else with. So again, this is going to involve some things you've learned in the past. Okay, so this is going to be 3x squared minus the square root of 36 is 6. Now let's talk about this right here, x cubed. Okay, so remember what we did here. So 3 is odd, right? But the question is, can I still simplify this? Yes, because 3 is greater than or equal to 2. And so remember how we wrote this. We asked ourselves, since this is odd, we asked ourselves, was the largest whole number less than 3? That's even, and the answer is 2. So what we did was we wrote this as the square root of x squared times x. So this should be coming back to you. Remember all this? And so now we use the product rule. So it'll be the square root of x squared times the square root of x. And now the square root of x squared. So what times itself? See, this is even now. This is even. Remember square root. So whenever it's square root and the exponent is even, then do it this way. What times itself twice is x squared? The answer is x. And then notice, can I simplify the square root of x? No, because the exponent 1 is less than 2. So it's less than the index. So this goes here. So it'll be 6x square root of x. Okay? And then plus, and then we already dealt with this. That's this right here. So x square root of x. Okay, so that's where I'm at. So notice I simplified all 3 radicals. This radical simplifies to this. This term simplifies to this. This term simplifies to this. Okay? Now let's combine like terms. So now we're going to combine like terms. Okay? So which ones are like terms? So remember, I have radicals here. So notice that these 2 terms have a square root of x. They also have the variable x attached to it, right, as a factor. And notice that the exponents are the same. So are these like terms? Yes. Is this term like any of the others? No. For one thing, the x has an exponent 2, and there's no square root of x. There's no square root of x. All right, so see, these have radicals in it. This does not. But these are like terms. They definitely are like terms. So I can combine those. And so basically you just look at the coefficient, have negative 6x squared of x, and have a positive 1 x squared of x. So what's the negative 6 plus 1? So if you don't know it, use your calculator. Negative 6 plus 1 is negative 5. So this becomes 3x squared minus 5x squared of x. That's the answer. Okay, so these are like terms, and that gives you this right here. Now, if you want to rewrite this, you can remember addition is commutative, so I can rewrite this as negative 5x squared of x plus 3x squared. Okay. All right. So that's number 2. Let's look at number 3. So this topic, this lesson is a little bit more challenging because of all those variables. All right, but the more practice you do with it, the better you get. All right, number 3, let's suppose you had this problem. You have 3 square root of 16y to the 5th minus the square root of 49y to the 5th. Okay? All right, so notice that these radicals are not like terms right away because the radicands are different. So let's go off to the side. Actually, let's use a product rule with these first, just like we did with every else, all the other two problems. So we're going to stay consistent with with what we've been doing. So this is 3 times the square root of 16 times the square root of y to the 5th, right? Minus, and this is square root of 49 times the square root of y to the 5th. So just using the product rule. Okay, so I know the square root of 16 is 4, so this will be 3 times 4. Okay, now let's talk about the square root of y to the 5th. Let's go off to the side, square root of y to the 5th. So we're trying to simplify this radical. So I know I can simplify this because the exponent is greater than or equal to 2. Okay, so remember we said what's the largest, since this is odd, what's the largest whole number less than 5 that's even? So the answer is 4. So you say y to the 4th times y. Now using a product rule in this, I get the square root of y to the 4th times the square root of y. And then what's the square root of y to the 4th? What times itself twice is y to the 4th? This is even, so it's even, then this part's easy. That's just going to be y squared. 4 divided by 2 is 2, y squared. And then I cannot simplify this any further because the exponent's 1 and 1's less than 2. It's less than the index. And so that's going to go here. So y squared, square root of y, okay? Minus the square root of 49, that's 49. Square root of 49 is 7, and then we already talked about this. This is this, right? So y squared, square root of y. Okay, now let's go ahead and simplify this term a little bit better. 3 times 4 is 12, so you get 12y squared, square root of y, minus 7y squared, square root of y. So that's where I'm at. So I want you to notice, though, that this term is simplified to this. This term is simplified to this, and this was the work we had to do to get to this point. Now, the next question, are those like terms? Okay, look at the radicals first. Are the radicals the same? Yes. Now, I have some variables attached to it as factors. I have 2 factors of y here. Do I have 2 here? Yes. So they are like terms. So notice that this is the same as this. So now all I do is look at their coefficients. 12 subtract 7 is 5. So I get 5y squared, square root of y. And so that's the answer. Okay? That's a y right here. All right. Number 4, we have 3 square root of 8x cubed plus the square root of 2x. So 3 times the square root of 8x cubed plus the square root of 2x. So again, we're going to do the same idea we did this at this point. So here I can rewrite this as 3 times the square root of 8 times the square root of x cubed plus. Now here I'm not gonna do the product rule here. Why not? Because 2, there's no perfect square that goes into 2, and then I cannot simplify the square root of x because this exponent is 1. So this is already simplified. I can't simplify that any further. So don't waste your time doing the product rule here because this is going to be the square root of 2x throughout. Okay? All right, now let's go ahead and talk about the square root of 8. So let's remind ourselves how to simplify the square root of 8. What's the largest perfect square that goes into 8? Okay, 4. So this would be 4, square root of 4 times 2. Using the product rule here, that's going to be the square root of 4, square root of 2. So I get 2 square root of 2. The square root of 4 is 2. So that goes here. So I get 3 times 2 square root of 2. So that's this right here. And let's talk about the square root of x cubed. So remember the square root of x cubed, 3 is even, and I can simplify this. So I'm going to remember the largest whole number less than 3 that's even is 2. So I'm going to rewrite this as square root of x squared times the square root of x. Okay? And the square root of x squared is just x. I get x square root of x. It's kind of like we had in the previous problem, in another problem that we did. So this right here becomes x square root of x plus this right here plus square root of 2x. Okay, now let's go ahead and rewrite this in a better way. Okay, so 3 times 2 is 6. Y'all agree? And then remember the square root of 2 times the square root of x. Think about that. Square root of 2 times the square root of x using the product rule, since they have the same index, is the square root of 2x. But let's go ahead and put this x in front between the 6 and the square root of 2x. Let's go ahead and do it like this. So So notice that this is now this. Look, 3 times 2 is 6, right? The square root of 2 times the square root of x is the square root of 2x, and then you have that extra factor of x here. Okay? Plus, and then square root of 2x. Okay, so here's the question. Are those like terms? No, those are not like terms. Why not? Although they have the same radical, square root of 2x, this has an x as a factor, this does not. So that's your answer. You're done. Okay? Now I'm just going to ask you, if this was an x right here, suppose you had this. 6x square root of 2x plus x square root of 2x. Could I combine those now? Yeah, you can combine those now. It's kind of like in the previous one, right? Y squared square root of y squared square root of y, 12 minus 7 is 5. But over here, you could not combine those because this has a square root of 2x, this has square root of 2x, but you have that extra factor of x, and this does not. So this would be your answer. But if you had this, then this would be 6 plus 1 is 7, so it would be 7x square root of 2x. That would be the answer there. Okay? All right, so know when you can combine, when you can combine, and when you cannot. All right, let's do number 5. Number 5, let's suppose we had this for number 5. So let's suppose we had the square root of 6x squared plus x square root of 96. So square root of 6x squared plus x square root of 96. Okay, so again, let's use a product rule to help us. So this will be the square root of 6 times the square root of x squared plus x, and then let's go ahead and just rewrite this as 96 since there's no variable there. Okay, now can I simplify the square root of 6? No. Can I simplify the square root of x squared? Yes, because what's the square root of x squared? X. Now again, we're assuming that all variables are positive, so we don't have to worry about absolute values at all. All right. So this is square root of 6 times x, right? Or x square root of 6. So let's go ahead and write it like this, x squared of 6. Plus, okay, let's talk about the square root of 96. So what's the largest perfect square that goes into 96? Let's just try 16, see what happens. 96 divided by 16. Okay, so 16 is it. So that'll be the square root of 16 times the square root of 6, right? And so the square root of 16 is 4, so you get 4 square root of 6. So this will be x times 4 square root of 6. Okay? And so here's the question. So you see I have x squared of 6, x in front of the square root of 6. Let's rewrite this so it looks kind of like this. It'll be 4x squared of 6. Y'all agree that this is the same thing as this? I just put the factor of 4 in front. Now, how many of these x squared of 6 do I have here? I have 1. How many do I have here? So those are like terms, right? Those are like terms. So these are like terms. I have 1 plus 4 gives me how many? 5. So I get 5x squared of 6. All right. And now if you want to write the answer as put where the factor of x is listed last, that's fine. But we prefer to, it depends on the textbook. So some textbooks will put the square root at the end, some will put the variable at the end. It does not matter. I prefer it this way. And the reason is sometimes when you put the square root in the middle and you extend this too far, it looks like this is underneath, and that's not supposed to be. All right, so that's why we tend to write it like that. Okay, so number 6. Number 6, let's suppose you had 6 square root of 12x squared minus 2x square root of 3. Okay, so first of all, can I simplify any of this right here? That square root of 3? No. So I'm not gonna rewrite this like I did with a product rule or anything like this, because this is gonna stay the same throughout. But here, see, I can simplify the square root of 12 and I can simplify the square root of x squared. So let's break it down using a product rule first. So that's 6 times the square root of 12 times the square root of x squared. Minus, and just rewrite this over. Okay? Now let's go and talk about the square root of 12. So how can it simplify the square root of 12? What's the largest perfect square that goes into 12? Okay, 4. So 4 times 3 is 12, right? So it'll be the square root of 4 times the square root of 3. And the square root of 4 is 2, so you get 2 square root of 3. So this right here becomes 6 times 2 square root of 3 times, and then remember the square root of x squared is just x. Okay, minus, and then just rewrite this over. Okay, now you see how this is written as 2 times x squared to 3? So let's kind of rewrite this, if we can, looking like this. So 6 times 2 is 12, right? And I'm going to put the factor of x between the 12 and the square root of 3. So you agree that this is still this. And then minus 2x squared root of 3. So then the question is, are these like terms? Yes, because they both contain x squared root of 3. So these are like terms. So the radicals are the same, the index is the same, and the radicand's the same, and they both have a factor of x to the first. So then all I need to do is look at the coefficient, the factor that does coefficient. The number 12 subtract 2 is 10. So I get 10x squared root of 3. And so that's the answer. Okay? Number 7. Number 7, let's suppose, and let me use another sheet of paper for number 7. So number 7, let's suppose we have this for number 7. So number 7, we have, all right, let me move this over. All right, so number 7. All right, number 7. Okay, so we have 11 square root of 27 y squared a plus 10y square root of 12a. Okay? All right, so that's what we have. Okay, so again, let's just go ahead and use the product rule to rewrite this. So I get 11 times the square root of 27 times the square root of y squared times the square root of a. You'll agree? So I can take the square root of all those factors. Plus 10y times the square root of 12 times the square root of a. All right, now let's go through each one and see if I can simplify those any further. So the square root of 27, what's the largest perfect square that goes into 27? All right, 9. So it'll be the square root of 9 times the square root of 3, because 9 times 3 is 27. And the square root of 9 is 3, so I get 3 square root of 3. So that is this. So I get 11 times 3 square root of 3. Now let's talk about the square root of y squared. Can I simplify that? Yes, because the exponent is greater than or equal to the index. So that's just, remember, you're asking yourself, what times itself is y squared? Well, y times y is y squared. So that's y right here. And then can I simplify the square root of a? No, because the exponent of 1 is less than 2. Okay, so that's what we have. Plus 10y. Now let's talk about the square root of 12. Square root of 12, that's going to be the square root of 4 times square root of 3, right? 4 times 3 is 12. And then square root of 4 is 2, so that's 2 square root of 3. Okay? And so this right here would be times 2 square root of 3. And then I cannot simplify the square root of a, so I'm going to rewrite it. Okay, now let's try and simplify this a little bit further. 11 times 3 is 33. The square root of 3 times the square root of a. So remember what I'm asking. The square root of 3 times the square root of a, I can write as 1 square root. And what is it? The square root of 3a. And then we have a factor of y. So I'm going to write this as 33y times the square root of 3a. So that is this. Plus 10 times 2, 10 times 2 is 20. So I get 20y, and then the square root of 3 times the square root of a, we already talked about, that's the square root of 3a. Okay, now here's the question. Are those like terms? Yes, those are like terms now, because they both contain y square root of 3a. So the radicals have the same index and the same radicand, and then you have an extra factor of y in both. So all you got to do is look at their coefficients. 33 plus 20, 33 plus 20 is 53. So you have 53y square root of 3a. So that's the answer there. Okay. Number 8. So you should be getting a little bit better at this. The more problems we look at, the easier it becomes. So let's look at number 8. Suppose we had the square root of 40x plus 2 square root of 40x to the 4th minus 3 square root of 10x minus the square root of 5x to the fourth. All right, so I have those four terms. Okay, now remember you want to try and simplify those four terms to see if any can be like terms, okay? So I can simplify the square root of 40. So I'm going to rewrite this because the 4 will go to the 40. So I'm going to rewrite this using the product rule. So it'll be the square root of 40 times the square root of x, right? And I can simplify this further. So I'm going to use the product rule again. 2 times the square root of 40 times the square root of x squared. Now here's a question. Can I simplify this any further? Besides 1, is there another perfect square that goes into 10? No. The exponent here is 1. 1's less than 2, so I cannot simplify this. So I'm not going to use the product rule because this is going to stay the same throughout. So it'll be minus 3 square root of 10x. But I can simplify this because of that 4 right here. So I'm going to rewrite this as the square root of 5 times the square root of x to the fourth. Okay? All right. Now, let's talk about the square root of 40. So can I simplify the square root of 40? Sure you can, because 4 goes into 40, and that's the largest perfect square. So we square root of 4 times square root of 10. So that square root of 4 is 2, so you get 2 square root of 10. So that goes here. So this part's 2 square root of 10. Can I simplify the square root of x? No, because the exponent is 1, 1's less than 2. Plus 2, I already talked about the square root of 40 already, so that's 2 times the square root of 10. And then remember the square root of x squared, I can simplify to, and that's an easy kind because the exponent's even. So what times itself twice is x squared? X. So that's going to be times x right here. This I cannot simplify, so I'm just rewrite it. And then here, I cannot simplify the square root of 5, so I'm going to rewrite the square root of 5. But I know that the square root of x to the fourth, since 4 is even, that's the easy kind. 4 divided by 2 is 2, so that means that this will be x squared. And it's true because x squared times x squared is x to the fourth, which is the radicand. So it'll be x squared right here. Okay? All right, so let's kind of rewrite this over. So this, the square root of 10 times the square root of x is the square root of 10x. So 2 square root of 10x. That's what I get here. Over here, 2 times 2 is 4, right? Now be careful. Don't say this is square root of 10x because that's not the square root. You understand? That's just x, right? Okay, that's just x. So that means 2 times 2 is 4. Don't forget that's plus 4x square root of 10. Okay, so that's the difference there. Okay, minus 3 square root of 10x, and then all I can do is just rewrite this. I'm going to put the x squared in front. So it's x squared, square root of 5. So I put the radicals in the end. Okay, so now this is a little bit more difficult. I have simplified, though. The square root of 40x ends up being this. 2 square root of 40x to the fourth ends up being this. This stayed the same throughout because I could not simplify any of that. I could not simplify this any further. This term becomes this. Okay? Now, which ones are like terms, if any? Let's see. Okay, so I found it. So do y'all agree that these two are alike? And there's nothing else, right? Now, don't say, well, what about this one? Because this is x squared of 10. This is square root of 10x. See, the x is under the radical. So these are the only two that have the same radicals with the same index and radicand. The radicand is 10x, the radicand is 10x. Okay? Here, my radicand is 10. Here, my radicand is 5. So those are the only two. So it's 2 and a negative 3. Okay, negative 1. So I get negative square root of 10x, and just rewrite the other two, plus 4x square root of 10 minus x squared square root of 5. And again, you could rewrite this in any order, by the way, in any order. So if you want to put this first, you can. So you can say 4x squared root of 10. If you want to put this second, you can, minus square root of 10x. And then then you can put this last. Or if you want, you can put this first, this second, this third. You see there are multiple ways of writing the answer as long as you write the terms correctly. Okay? So just make sure that if you put this first, it's positive. If you put this second, you write as a subtraction, and so on. Okay? All right, so that was a little bit more challenging. All right, and let's go ahead and do one more. Let's just do one more. And then And I suggest that you go back, guys, go back and rewrite the problem and see if you can do this over by yourself. This was challenging. Some of this is not too bad. Some of it is a little bit more involved. See how involved it can be? Some of it's pretty involved. Okay? All right, number 9. We have the square root of 100 x squared plus 6 square root of x minus square root of 49 x squared. So sometimes you're going to get problems that look pretty, well, that will end up being nasty, so to speak. See how pretty involved this is? And sometimes you end up with something like this, okay? So this is not too bad right here. So using a product rule, I can write this as square root of 100 times the square root of x squared. Can I simplify this? No. So I'm going to rewrite 6 square root of x. Using a product rule here, I get the square root of 49 times the square root of x squared, right? Okay. So let's talk about this one. What's the square root of 100? 10. What's the square root of x squared? So what times itself is x squared? X. So that's 10x. Y'all agree? I cannot simplify this. Let me rewrite it. Minus over here. What's the square root of 49? 7. What's the square root of x squared? Well, we already talked about that. That's just x. And you basically done. So you simplified this to 10x. This was already simplified. You could not do anything else to it. And you simplified this to this. So are any of them like terms? Yeah, these two. All right. This is not like terms with anything else. So therefore 10x minus 7x is 3x. You get 3x plus 6 square root of x. Or if you want to put the 6 square root of 3x first, you can. 6x. I'm sorry. 6 square root of x plus 3x. Does not matter. So see that one. So sometimes your problems are not difficult to deal with, and sometimes they are. Whenever you're dealing with variables, depending on where the variables are located and what needs to be simplified, it can be involved. If it's involved, though, like this one was, be very careful. Do some work on the side and think about every little part of detail. See how I wrote these out? Just like this. Just like this. And the more you do and the better you get at it, you can skip some of these steps. But for us right now, it is very important that you write it out step by step, just like I did. Do this, then you do this, go a little bit further, and then you get your answer. Okay? All right, so that is the lesson that dealt with simplifying, adding and subtracting square roots in which we had variables involved. Okay? All right, so that's the end of this lesson.